Welcome pre-cal students to the homework help video. The assignment is here in front of you, and please go ahead now and view the problems that you're struggling with. Okay, let's start with number 1. For numbers 1 through 19, 1 through 20, they're asking us to solve the equations. Now please notice this equation is equal to 0. Also notice it's already factored for you. So really all that you need to do is take each group and set each group equal to 0. It's already factored and the right side is equal to 0. So I won't spend a lot of time on this. The answer for this equation would be 3/2, and the answer to this equation would be 2/3. Okay, so there's your two answers, 3/2 and 2/3. All right, moving on to number 5. Now, this is a quadratic equation. Notice the right side is equal to 0. I believe the fastest way to solve these is to factor. That's my opinion. So I'm going to see if I can factor this. Notice your lead coefficient is 3. So 3 times -2 is -6. So I'm going to write a -6 over here. And then I realize, now watch this carefully, if I multiply these two numbers together, I get a -6, and if I add them together, I get a +1, which is the coefficient right here. So these are definitely the two numbers that I want to use right here. So I bring down my 3x squared, I bring down my -2, and right in the middle here, I'm going to put a +3x and a -2x. All right? Now for your first two terms right here, you pull out what's common, which is a 3x, and you're left with x plus 1. For these two terms here, you pull out what's common. Whenever this is negative right here, you pull out a negative sign, and a 2 is common. I'm going to put x plus 1 in this first parentheses because it should match this parentheses here. Let's see if it does. -2 times x is -2x, and -2 times 1 is -2. So we're good. Go ahead and write your matching parentheses one time, and then your other parentheses should be 3x minus 2. Now, if you take each group and set each group equal to 0 and solve, this group right here will give you out a -1 for an answer, and this group right here will give you out 2/3 for an answer. All right, let me grab a drink here. We'll continue on. Now on number 9, very quickly, I just want to show you something. You're welcome to factor this. Bring the 21 over and make it negative. Pull out a 3. And then take this group here and set it equal to 0 and solve. But I want to point out to you, there's really no need to do that. When you only have an x squared and no other term, look students, I would just simply get the x squared by itself, divide both sides by 3, and you're left with x squared equals 7. Now take the square root of both sides. The square root of x squared is x, and the square root of 7 would be plus, minus, or positive, negative, square root of 7. And that's it. I mean, there's really nothing else you can do except type that into your calculator and get a decimal answer, and we're not going to do that. So moving on to number 13. Once again, look, all that you have is an x squared term. There's no other variables up here. So instead of trying to factor, I would very quickly get the x squared by itself. I would bring the 34 over and make it a positive 34. I would divide both sides by 2. And then take the square root of both sides. The square root of x squared is x, and the square root of 17 is positive, negative, square root of 17. All right, and there we go. Moving on, not too difficult. Now, when I view this equation here, first of all, I notice that the right side is already equal to 0, which is good. I notice I do not have a quadratic equation. I have a third-degree equation. But students, please look. Every term has at least one y. So if I first of all pull out what's common, which would be a y, look what you're left over with. You're left over with a quadratic equation. Now, I'm going to factor this quadratic equation, or I'm going to try to. Notice I do not have a lead coefficient of 1. I have a lead coefficient of 3. So I multiply 3 times this number, and I put it over here. 3 times negative 2 would be negative 6. And now look, if I multiply negative 6 and positive 1, I get a negative 6. And if I add those two together, I get a negative 5. So these are my two numbers that I want to use for my two middle terms. So I'm going to forget about this y, okay? I'll bring it down later. Right now I'm just going to work with the trinomial right here. So bring down your 3y squared, bring down your negative 2, your equal sign, your 0. And right in the middle right here, we're going to put these two numbers right here. So negative 6y, positive 1y. There. Now, pull out what's common out of your first two terms. It's going to be a 3y, and that will leave you with y minus 6. In your second two terms here, pull out what's common, which is nothing. So just pull out a 1. And let's see, I made a mistake here, didn't I? It would not be, hold on one second. It would not be y minus 6. Sorry about that. It would be y minus 2. There we go. And then over here, if you pull out what's common, it would be just a 1. And you're left with y minus 2. Because 1 times y is y, and 1 times negative 2 is negative 2. Now you write your matching parentheses once. Your other parentheses would be 3y plus 1. Now don't forget, and I almost forgot myself, don't forget to bring this y down, okay? Now, would you please let me talk to you for a second about this y? Please listen to me, students. If this y would have been a number, let's say that you would have had pulled out, let's say that 2 went into all these numbers. Let's say you would have pulled out a 2. And so you would have had a 2 right here, okay? When you get to the end here, there's a y in this group, so you solve this group. There's a y in this group, so you solve this group. There's not a y in this group, so you don't worry about that group, okay? Now that's the case if you would have pulled a number out. But we didn't pull a number out, we pulled a y out, right? So is there a y? Look, if you would have pulled out a 2y like this, is there a y in this group still? Yes, there is. Any group that has a variable must be set equal to 0 and solved. So if you take y and set it equal to 0, you just get 0. There's one answer. If you take this group and set it equal to 0 and solve, you'll get 2. If you take this group and set it equal to 0 and solve, you will get negative 1/3. So there we go. There's 3 answers. Okay? All right, moving on to number 21. And now, for numbers 21 and 25, the directions say to list out the x-intercepts and the zeros. Now, we know by now they're the same thing. The only difference is they wanted you, I really am not that picky, the book wanted you to write your x-intercepts like this. -2, 0. And 1, 0. Do you see those two x-intercepts? There's one, and there's one. And actually, I think I'm wrong, and I apologize to you. It just dawned on me. You gotta be careful. Do you notice how the x-axis is in increments of 2, 2, 4, 6, 8, 2, 4, 6, 8? So really, with this point right here is 1, it'd be 2, 4. So your x-intercept would be -4, 0. And then this x-intercept is over 1 tick mark, that's 2. So the other x-intercept is 2, 0. And then they want you to list out the zeros, which of course I've taught you zeros are the same thing as your x-intercept, and they are. And they want you to write your zeros like this: -4, 2. -4 and 2. I'm really not that picky. You could have listed your x-intercepts just like this for me. You could have said -4, 2. I really wouldn't have cared, okay? But the main thing they're trying to show you here, or remind you of, or drill into your head, is that zeros and x-intercepts are the same thing. All right, number 25. They want us to list out the zeros and the x-intercepts. So very quickly I will do that. The x-intercepts would be Here's 1 and here's 1, and everything is in increments of 1. So one x-intercept is negative 2 comma 0. The other x-intercept is 2 comma 0. Now, if you list out the zeros, you will get plus minus 2. All right? Plus minus 2. We call the x-intercepts zeros. Hope that makes sense. Moving on to 29. Now, the directions for 29 and 33 say solve by completing the square. Solve by completing the square. So here we go. I have taught you that step 1 is to put your x squared and your x term on the left side and your constant term on the right side. So I'm going to take this 8x and bring it over here to the left side and make it negative. Okay, I've taught you to do that. Step 2, I've taught you to divide everything by the x squared coefficient. Well, the x squared coefficient is 1, so it really doesn't do a lot of good to divide everything by 1. So we're done with that, we're good. Step 3 says take this number right here that's with the x, divide it by 2 and square it. Now you're welcome to take the negative 8, but it really doesn't matter because you're going to square it in the end, which will make it positive anyway, so it doesn't matter. Take 8 and divide it by 2 and you will get 4. Then you take that number and you square it and you get 16. So if you want to use the negative 8, that's fine. Negative 8 divided by 2 is negative 4. And then when you square negative 4, you still get 16. Now what I've taught you to do next is to add that number to both sides. There we go. Now, notice this group here can be simplified. A negative 9 and a positive 6 would just be 7. All right. So we're moving along pretty well, not too difficult. The next step in your list of steps to do is to factor the left side. And I taught you a shortcut. I taught you to take the square root of this term right here in your head and put it here and here. I taught you to take the square root of this term in your head and put it here and here. And I taught you whatever this sign is right here, you bring that sign down and put it here and here. That's it. And now really, these two parentheses will always match. You really have x minus 4, x minus 4. So I'm just going to put x minus 4 squared. Now the reason I did that is I'm going to take the square root of one side as long as I can take the square root of the other side. Well, when you take the square root of something squared, you just get the base, which is x minus 4 equals positive negative square root of 7. And then obviously your last step is to bring the negative 4 over and make it a positive 4. So x equals positive negative square root of 7 plus 4. There we go. Not too difficult. So we solve the equation by completing the square. Let's take a look at 33. Okay, we're going to solve this by completing the square. Step 1 says to get the x squared and x terms on one side and bring the to the left side and bring the constant terms over to the right side. There. Step 2 says divide every term by the x squared coefficient. So I'm going to divide every term by 3 because I have a 3 right here. Well, if I divide this term by 3, I'm left with x squared. If I divide 5x by 3, I'm left with 5/3 x. And if I divide 2 by 3, I'm left with 2/3. Very good, no problem. Now moving on, the next step says to take your x coefficient, in this case it's 5/3, and divide it by 2. So 5/3 divided by 2, you can use a calculator if you need to, would give you 5/6, and then I've taught you to square that number, and if you square that you will get 25/36, and you're going to add that to both sides, okay? So x squared plus 5/3 x plus 25/36 equals 2/3 plus 25/36. 36th. All right. Now, if you look at the left side here, we should be able to simplify this pretty quickly. Your denominator is 36. Here, your denominator is 3. So if I made it a 36, that would be 3 times 12. So 2 times 12 would be 24. And so there we go. 2/3. And you can just use a calculator if you want and type in 2/3 plus 25, 36. I just quickly just found a common denominator, and now I can add these two fractions together. And if you add these two fractions together, you will get 49 over 36. So however you want to do that's up to you, but make sure you know how to add two fractions together. Now, next I've taught you to factor the left side, and I taught you how to do that using a pretty cool shortcut. Okay, and this shortcut only works when you're completing the square. You take the square root of this term here in your head, and you put it here and here. You take the square root of this term in your head, and you put it here and here. And then whatever your middle term is right here, you put that sign here and here. And now the reason it's so important that we do that is notice you have two identical parentheses. So really you can just cross one of them off and put a squared right here. All right, and it's important that we do that because we're now going to take the square root of both sides, and so it was very important that I had one side written with a power of 2. So what I'm going to do now is I'm going to take the square root of the left side, but I must also take the square root of the right side. Now notice the right side is a perfect square. I'm going to simplify that in just a second, okay? When you take the square root of something squared, you're left with just the base. So x plus 5/6. And then over here on the right side, the square root of 49 is 7, and the square root of 36 is 6. Don't forget your plus minus in front of it. Now bring your 5/6 over and make it a negative 5/6. And when you do that, you're left with positive negative 7/6 minus 5/6. Now, I'm going to write that two different ways because don't forget you have to consider the positive 7/6 and the negative 7/6 also, okay? So I'm going to put a positive 7/6 minus 5/6, and I'm going to put a negative 7/6 minus 5/6. 7 minus 5 is 2. That's 2/6, which reduces to 1/3. There's one answer. Negative 7 minus 5 would be negative 12 over 6, which reduces to negative 2. Let me get a drink here real quick. And there we go. We completed the square. Okay, and there's your two answers. Not too bad. Okay, now the next section tells us to solve the quadratic using the quadratic formula. And I think we have about, not too many of these. 1, 2, 3, I think 4 or 5 of these. So we'll do them pretty quickly. I'm going to go ahead and write the quadratic formula one time. And then I'm going to cut and paste this so I won't have to write it over and over. All right, give me just 1 second here. Okay, here we go. Never use the quadratic formula, never, unless one side is equal to 0. Very important. The quadratic formula will not work unless you have one side equal to 0. Now this is your A, this is your B, and this is your C. So here we go. Negative B, I'm going to substitute a 3, so negative 3. Under the radical, I have b squared. Go ahead and square the 3 in your head. 3 times 3 is 9. I like to bring down my negative 4 and then put a parenthesis for AC. Go ahead and do AC in your head. 5 times negative 2 is negative 10. All over 2 times A. Well, A is 5. 2 times 5, 10. Next, what I like to do is I like to simplify the radical. And we should be able to do this pretty quickly. Negative 4 times a negative 10 would give you a positive 40. and then add those two numbers, and you will get a positive 49 all over 10. Now we're cruising right along. Let's come over here and finish it. I now have negative 3 plus minus 7, because the square root of 49 is 7. And now I can take this and write it two different ways, because I have two signs right here to consider. So I would have negative 3 positive 7 over 10, and I would also have negative 3 negative 7 over 10. Now this one here would simplify down to what? Let's see. What's a negative 3 and a positive 7? That's a positive 4. So you have 4 over 10, which reduces to 2/5. So there's one answer. Now, the next answer, negative 3 and negative 7 up top, would simplify to a negative 10. So you really have a negative 10 over a negative 10 over a positive 10, which would give you a negative 1 if you simplified it. So there's your two answers. The quadratic formula is pretty simple to use. All right, number 41. All right, do we have one side equal to 0 already? Yes, we do. So my A equals 1 from here, my B equals 1 from here, and C equals 2. So here we go. Negative B, so negative 1 plus minus the square root of b squared, that's 1 squared, so a 1. 1 times 1 is 1. Then bring down your negative 4. Then go ahead and do AC in your head. AC is 1 times 2, so that would be a 2 all over 2a. A is 1, so 2 times 1 is 2. Now next, I want to go ahead and simplify my radicand. So go ahead and in your head you can multiply negative 4 times 2. Negative 4 times 2 would give you a negative 8, and 1 negative 8 would give you a negative 7. No big deal. We've dealt with negative radicands before, so let's continue this over here. The first thing I'm going to do is put negative 1 plus minus, and I'm going to make that negative 7 positive as long as I can put an I right here. All right. Now, every book is different, and I'm not sure how the back of the book works. I'm okay with this. I really am. A lot of books want you to split it up into two fractions, so it's in standard form. They want you to put, see this negative sign right here? They want you to put negative 1/2 and then plus minus the square root of 7 over 2i. I'm okay with this. I'm okay with this. But one thing I'm not okay with is this. Pretend for a second you would have had a 27 here. If you had a 27 here, don't forget, you could split that down into what? 9 times 3, and then cross off the 9 and put a 3 on the outside. So in other words, what I'm trying to say is always make sure to simplify your radicals if you can. That is something you must do, okay? All right, that's number 41. Moving on to number 45. And here we go. Well, you never want to use the quadratic formula unless one side is equal to 0. So I'm going to bring the 5x over, and I'm going to intentionally leave this thing written in non-standard form. I'm doing that for a reason. I want to make sure you realize that your a always comes from your x squared term. Your c is your constant term, and then your b is your x coefficient. Okay, so I just kind of want to leave it out of order so you wouldn't think it's always A, B, C. That's not true. You have to look at what each term is. Okay, now let's come over here. Notice I have a negative B. B is negative 5. So if you put a negative 5 in and there's already a negative sign here, you end up with a positive 5. And then under the radical, we're going to square B. So you can square negative 5 in your head. You would get 25. Then bring down your negative 4, and you should be able to do AC in your head. 3 times negative, oh, my bad, hold on one second. 3 times 4, 3 times 4, which would give you 12. All right, and then 2a, a is 3, 2 times 3 is 6. Now for me, I like to simplify the radicand next. So a negative 4 times 12 would give you a negative 48. negative 48. Okay, and so when you combine those two, a positive 25 and a negative 48, you're going to get a negative 23. Negative 23. All of that is over 6. And again, this is really pretty simple. I'm going to go ahead and make that positive, put an I here, and I'm finished. You cannot simplify the square root of 23. If you would like to write your answer like this, I have no problem with that. I probably prefer this. It is a lot more mathematically accepted, but I will allow either answer. Okay, there we go. Moving on to 49. Okay, we're going to use the quadratic formula like the directions have said to do. So in order to do that, we must get one side equal to 0. So we're going to bring the 5 over, and when we bring it over, we will make it a negative 5. And now let's get started. A equals 3, B equals 1 from right here, and C equals negative 5. Now, negative B is 1. Put a 1 in for the B. Negative 1 plus minus the square root of b squared, where the b is, put a 1. 1 times 1 is 1. Negative 4. AC. A times C. That would be a negative 15. All over 2 times A. A is 3. 2 times 3 is 6. Alright, now I'd like to simplify my radicand next, so here we go. Negative 1 plus minus. Now, we have a negative 4 and a negative 15. When you multiply a negative times a negative, you're going to get a positive 60. So a negative 1 and a positive 60 is 61 all over 6. Now students, look, you can't simplify. As far as I know, there's no number that goes into 61 evenly. Okay, so none of your perfect squares are going to go into that number evenly. So this is your answer. You cannot simplify the 61. Let me say something right now. A lot of students think if there was a 2 right here, you could reduce the 2 and the 6, and you can't because you have 2 terms in your numerator. Now, if there was a 4 right here, then you could reduce this, and this by 2. But you cannot do that if there's no number right here in front of the radicand, okay? So anyways, here's your answer. If you would like to write your answer like this, feel free to. Negative 1/6 plus minus the square root of 61 all over 6. That's totally fine, okay? All right, number 53, and we're finally finished. We're going to solve this using the quadratic formula. And so here we go. First of all, you must get one side equal to 0, so I'm going to bring my negative 2 over, and when I do, it becomes a positive 2. And then here we go. My A equals 5, my B equals 2, and my C equals 2. So here we go. I have negative B. B is 2, so I'll have a negative 2. Plus minus the square root of b squared. B is 2, square the 2, and you get a 4. And then next is minus 4ac. Let's do ac in our head. 5 times 2 would be 10, all over 2a. Well, a is 5, 2 times 5 is 10. Next, let's simplify our radicand. We should be able to do that pretty quickly. You have a negative 4 times 10. Cross that off. That's going to be a negative 40. Negative 40. Now 4 minus 40 is a negative 36 all over 10. We've got some simplifying to do in this problem. First of all, with my radical or my radicand, I'm going to go ahead and make the 36 positive and put an I right here like we've learned to do. And then next, I realize 36 is a perfect square, so now I have negative 2 plus minus 6i all over 10. Do you see that okay? Because the square root of 36 is 6. And now look at all three numbers. You can reduce all three numbers by 2. Okay? Let's create a little more space here. All right. reduce everything by 2, so 2 goes into 2 once, 2 goes into 6 3 times, 2 goes into 10 5 times. So you're left with negative 1, positive negative 3i all over 5. And you know what? I'm fine with that answer. I don't prefer it, but I'm fine with that. Because you have a negative 1, another way to write the answer would be negative 1/5, and then put your plus minus, and then put your 3/5 with an I. There we go. Both of those answers are acceptable. Okay? All right, let's move on now to number 61, and we're doing 61, 63, and 65. Now, the directions say to find all of the zeros. So for 61, 63, and 65, we're finding zeros. Now, don't forget, when the directions say to find zeros, you're really finding x-intercepts. And so if you're finding x-intercepts, we're going to call f of x y. If you're finding x-intercepts, you always put 0 in for y. So I'm going to go ahead and put 0 in for y. And as soon as I put 0 in for y, you just got a good old-fashioned quadratic equation. I mean, our number one method we like to use is factoring if we can. I've got a lead coefficient of 1, so that's the easy kind. Let's think about this. Positive 5. Well, how about this? If I take a positive 5 and a positive 1 and multiply them together, I get 5. If I add them together, I get 6. So I can definitely jump right to the parentheses part, and I can put x plus 5, x positive 1 or plus 1, whatever. So there we go, I factored it. Now if you take this group and set it equal to 0, you will get a negative 5. And if you take this group and set it equal to 0, you will get negative 1. So you just found the zeros or the x-intercepts for 61. There you go, that easy. Nothing to it. Okay, moving on now to number 63. Well, they want us to find the zeros, which means we're looking for the x-intercepts, which means we're going to put a y here. And now, anytime you're looking for x-intercepts, you put a 0 in for y. If I was looking for the y-intercept, I would put zeros in for x's. So here we go. Let's put a 0 in for y because we're looking for x-intercepts. And let's see if we can factor this. I don't think we can. I cannot think of any two numbers when multiplied together that would give you, let's see, a negative 3. It would have to be 3 times 1, 3 times 1. And no, none of those work. So we cannot factor this. So we go back to our good old standby, which would be the quadratic formula. So this is really easy. A equals 1, B equals negative 3, C equals negative 3. I mean, you can only use the quadratic formula when you have a quadratic equation, and we have a quadratic equation right here. So, no big deal. Here we go. Where the b, I've got negative b, and b's a negative 3. So I put a negative 3 in. Negative negative gives me a positive 3. Positive negative, square root of b squared. Negative 3 squared, that's 9. And then negative 4ac. Well, a times c would be negative 3 all over 2a. A is 1, 2 times 1 is 2. Now let's simplify the radicand. Negative 3 times negative 4 would be a positive 12. 9 plus 12 is 21. And students, there really isn't much more you can do with this, okay? Except type it into a calculator. Now you're welcome to type in 3 plus the square root of 21. Be sure and hit enter, and then divided by 2, enter. And then you could type in 3 minus the square root of 21, enter, or equals, divided by 2, equals, and get your answer. But this is also sufficient right here. So it all depends on whether you're trying to actually graph this and you wanted to know what the exact x-intercepts were, then you'd want to type this in and get out a decimal. Or you would want to see if you're trying to just write your answer in radical or exact number form, and that's what we did here. Okay, and then lastly, number 65, they want us to find the zeros of this function, which means I'm looking for the x-intercepts. So in order to find x-intercepts, I'm going to put 0 where y is. So 0 equals x squared minus 5x plus 1. You cannot factor that. There's no way. So I'm going to very quickly use the quadratic formula. I'm allowed to do that because this is definitely a quadratic equation, okay? And here we go. There we go. Now, we start off with negative b, and b is already negative, so a negative negative 5 is a positive 5. Positive negative square root of b squared. If you square negative 5, you're going to get 25, and then minus 4 or negative 4 ac. 1 times 1, 1. All over 2 times a. A is 1. 2 times 1 is 2. And now we're going to simplify the radicand. So we have 5 plus minus the square root of negative 4 times 1 will just give me a negative 4, and 25 minus 4 is 21. So it's kind of funny. We get the exact same radicand as the last problem, and you cannot simplify 21. None of your perfect squares will go into 21. So that's your answer, again, unless you want to type into your calculator and get out decimal answers. Okay? All right, moving on now to numbers 77 to 91, the odds. And now things are going to get really crazy, so please pay attention and watch what to do. I taught you in your notes, anytime you have a trinomial, and this power here is twice as big as this power here, you can go ahead and factor it like a normal quadratic trinomial. I did not say you could use a quadratic formula. You cannot use the quadratic formula because this is not a quadratic equation. We have a power, our highest power is a power of 4. Notice on your last problem, your highest power was a power of 2, and that's why it's called a quadratic. But you can still factor this as long as you make a couple of improvise a little bit along the way. Okay, now let's go ahead and see. We have a lead coefficient of 1, so that's the kind that we like. We have one side equal to 0, so we're ready to factor. So we're dealing with positive 2. So I'm thinking if I take a negative 2 and a negative 1, if I take negative 2 times negative 1, I get a positive 2. And if I combine those two, I'll get a negative 3. So I'm ready to jump right to my parentheses part. But hold it. You're used to putting an x right here, like x minus 2, x minus 1. Hold on. You have to look at your middle term. It's x squared, so you're going to use an x squared and an x squared. Now, let's take this group and set it equal to 0. Bring the 2 over and make it a positive 2. And now take the square root of both sides. And the square root of 2 is just positive negative square root of 2. Now let's do the same thing with this group. X squared minus 1 equals 0. Bring the 1 over and make it a positive 1. And now take the square root of both sides, and you will get positive negative 1. There we go. This works every time as long as you have a trinomial and the one side is equal to 0, and this exponent here is twice as big as this exponent here. Moving on to number 79. Well, I'm going to get the right side equal to 0 and see if I can't factor this thing, okay? I think that'd be a very smart thing to do. So, x to the 4th positive 3x squared minus 10 equals 0. Now, I have a trinomial, that's good. One side is equal to 0, that's good. And this exponent here is twice as big as this exponent, that's good. Well, let's see if I can factor this. I have a negative 10 right here. So, I'm thinking, what two numbers multiply together give me negative 10, when I add together give me a positive 3. How about this? If I have a positive 5 and a negative 2, if I multiply those, I get a negative 10. If I combine those, I get a positive 3. So I'm ready to jump right to my parentheses step, but don't forget, don't use x, use x squared, because that's your middle term. So x squared positive 5, x squared negative 2. All right, now, let's be very careful here. Watch this first group. When you set it equal to 0, notice you're going to get a negative 5 when you bring the 5 over. So you are going to have an imaginary number for one of your answers. When you take the square root of both sides, you will get x equals positive negative square root of negative 5. And of course, we're going to make that positive and put an I right here. So there's two imaginary answers. Over here, x squared minus 2 equals 0. Bring the 2 over and make it a positive 2. Take the square root of both sides and you'll get positive negative square root of 2. Now, Mr. Earhart, do we have to include imaginary numbers in our answer? Well, it depends on the directions. These directions simply said to solve, so I would include them as your answer, yes. And then also, sometimes the directions will say list all answers, real and imaginary. Sometimes the directions will say just list out real answers. If I would have asked for real answers only, you would cross that off and just give me that for an answer. So it really comes down to whatever the directions say. All right, let me grab a drink here. And let's continue on. Number 81. Okay, same problem again, so a little redundant here. I'm going to go a little faster. We have one side equal to 0. This power here is twice as big as this power. Two numbers multiply together, -5, +4. I'm thinking this right here. If I have a +5 and a -1, I multiply them, I get a -5. If I combine them, I get a +4. So I'm ready to jump right to my parentheses mode. Y squared +5, y squared -1. All right. Now I'm not going to keep doing all this for you. I've done a couple. You should be able to see by now. You take this group, set equal to 0, bring the 5 over, make it a -5. Take the square root of both sides, and you're going to have the square root of a -5. So what you'll end up with is positive negative square root of 5i. Over here, set this group equal to 0, bring the 1 over, make it positive, take the square root of both sides, and the square root of 1 will be positive -1. So there are your 4 answers, 2 answers here and 2 answers here. Okay, now we get into the fun ones finally. Listen, I know they give you these hints. I didn't teach it that way. You're welcome to use their hints. I have no problem with that. I'm just going to stick to the way that I taught you. I have x minus 3. Now I hope you've been taught this in the past. The square root of x, there's a 2 here, square root, and there's a 1 here. You can rewrite that as x to the 1/2 power. You really should have learned that in algebra 2. So we have -3, and the square root of x means x to the 1/2 power minus 4. So I didn't change anything. I just rewrote the problem in a different form. Okay, why did I do that? Well, I'm glad you asked. Let me tell you why. Remember, first of all, do I have a trinomial? Yes. Second of all, do I have a 0 here? Yes. Well, third of all, this power here has to be twice as big as this power here, and it is. 1 is twice as big as 1/2, so I can go ahead and factor this. So what two numbers multiplied together give me a -4? When added together give me a -3. Well, I'm thinking of these two numbers right here. If I multiply these two numbers, I get a -4, and if I combine these two numbers, I get a -3. Okay, so I'm ready for my 2 parentheses. Look at your middle term. It's x to the 1/2. So I'm going to write x to the 1/2 -4, x to the 1/2 +1. Now here's where it gets a little confusing, and you'll be okay. X to the 1/2 minus 4 is really the same thing as the square root of x minus 4 equals 0, right? I just showed that to you earlier. The square root of x is the same thing as x to the 1/2. So let's go backwards. X to the 1/2 is the same thing as the square root of x. Well, Mr. Earhart, why didn't you just leave it square root of x? Because I wanted to show you this power has to be twice as big as this power in order for you to factor this trinomial in the way that we factor. All right, now bring the 4 over and make it a +4. So I have the square root of x equals 4. And now look, how do you get rid of a square root? You have to square it. So if you square one side, you must square the other side. When you square a square root, you get what's on the inside, x, and when you square 4, you get 16. So there we go, there's one answer. Now let's come over here, let's try the same thing. I have the square root of x, x to the 1/2, square root of x, plus 1 equals 0. Bring the 1 over and make it a -1. And now you square both sides. Square the square root, square the -1. Now, when you square a square root, you get what's on the inside. When you square a -1, you'll get 1. Now, here's the problem. And remember, let me get a drink here real quick. Again, you really should have had this in algebra 2, but if you didn't, please listen carefully. anytime you square an equation, you very often get extraneous solutions. Now, extraneous solutions is just a big word for the word extra. You get extra solutions that sometimes don't work. And so anytime you square both sides of an equation, you have to check and make sure your answers work. So real quick, if I put a 16 right here, the square root of 16 is 4. 4 times negative 3 is negative 12. I have a 16 right here. 16 minus 12 is 4. 4 minus 4 is 0. So the 16 worked fine. But when you put the 1 in right here for x, it doesn't work. Put a 1 here and put a 1 here and watch what happens. The square root of 1 is 1 times 3 is negative 3. So I have 1, negative 3 minus 4. That doesn't give me 0. So this answer here does not work, so you do not include it. Can I show you another reason it doesn't work? Please watch this carefully. Anytime you square an equation and the number over here is negative, that's when you're going to get out an extraneous solution. Okay, so you can just about 99.9 if not 100% of the time take that to the bank. That's the answer you really want to check carefully. Okay, here we squared both sides of the equation, and notice the whole number that we squared was already positive, and that answer worked just fine. Here the number that we squared was negative, and this answer did not work. So look for that. That's a little secret that will help you usually catch the extra solutions. Okay, all right, moving on to number 85. Okay, again, forget the hint. Let's do this the way you've been taught. Do I have a trinomial here? Yes. Do I have a one side equal to 0? Yes. Is this exponent here twice as big? Well, let's see. Let's take 1/3 and let's multiply it by 2. And what do we get? 2/3. So yes, 2/3 is twice as big as 1/3. So everything checks just fine. So we can factor this like always. So here we go. I'm dealing with a negative 8, so I'm thinking right away, okay, if I take a negative 4 and a positive 2 and multiply them, I get a negative 8. If I combine them, I get a negative 2. So I'm ready to factor. I am so ready to factor. And what I have, my middle term is m to the 1/3. Since it's m to the 1/3, if it's okay with you guys, I'm going to go ahead and put cubed root. So the cubed root of x minus 4. And then instead of putting m to the 1/3, I'm going to put the cubed root of x plus 2. And now let's take each one of these groups and solve them. So the cubed root of x, now by the way, do you see why it's the cubed root? Because I have 1/3. In the last problem we had 1/2, and 1/2 meant a square root. 1/3 means a cubed root. So I have the cubed root of x minus 4 equals 0. Bring the 4 over and make it positive. Okay, and now how do you get rid of a cubed root? Well, you cube both sides. So when you cube a cubed root, you're left with the inside. When you cube 4, you get 64. Now let's come over here, and you're going to think right away, because of what I said in the last problem, that you're going to have an extraneous solution here, and you're not. I'm going to show you why in a second. Bring the 2 over and make it a negative 2. And now, of course, if you want to get rid of a cubed root, you cubed this side, so you must cube the other side. When you cube a cubed root, you're left with x, and when you cube a negative 2, you get a negative 8. Negative times a negative times a negative. Now, I want to go back to the last problem real quick and talk about extra solutions. When I mentioned if you square a negative number, I should have said something and I didn't. I apologize. That tip that I gave you with extraneous solutions almost always only works when you have an even power. So like you're squaring both sides, or you're raising both sides to the 4th power, or you're raising both sides to the 6th power, or you're raising both sides to the 8th power, etc. Okay, notice in this problem here we're raising both sides to the 3rd power, and that's an odd number. And so you might have extraneous solutions, but usually you won't. Okay. So in this problem here, and by the way, when you see this 2/3, you're like, what's 2/3 mean? Well, look, your calculator will do it for you. Just type in 64 and raise it to the 2/3 power, and you'll get 16. Put a 64 in here. 64 to the 1/3 power is 4 times negative 2 is a negative 8, and then here's a negative 8. You get 0. Everything works out perfectly. Now let's substitute negative 8 in. If you type into your calculator negative 8, and take the 2/3 power of that, I believe, let me check this, that you will get, yes, take your calculator, put it in parentheses, -8 to the 2/3 power, you will get out a +4. And then if you put a -8 in here, -8 to the 1/3 power does give you a -2, times a -2 gives you a +4, and then -8, and you do get 0. So both of these answers do work, okay? Learn to use your calculator and check your answers. Both of these do work. All right, number 87. All right, well, the same thing. Do we have a trinomial? Yes. Do we have one side equal to 0? Yes. Is 1/2 twice as big as 1/4? Well, of course it is. If you take 1/4 times 2, you'll get 1/2. So we're all set. We have a -2 or +2 here and a -3. I'm thinking of these two numbers. If I take a -2 and a -1 and multiply them together, I get a +2. If I combine them, I get a -3. So I am totally ready to factor. And notice my middle term is x to the 1/4. I'm going to go ahead and put the 4th root of x, if that's okay with you guys, and then -2. And then instead of putting x to the 1/4, I'm going to put the 4th root of x -1. And now here we go, guys. Take this group here and set it equal to 0. Think about this. 4th root of x -2 equals 0. Bring the 2 over and make it a +2. And now how do you get rid of a 4th root? Raise it to the 4th power. Raise this side to the 4th power. The 4th root to the 4th power is what's on the inside. 2 to the 4th power is 16. And so there's one answer. We're going to check it later for extraneous solutions. Then over here I have the 4th root of x -1 equals 0. So next I have the 4th root of x equals 1. Bring the 1 over, make it positive. Because you have a 4th root, raise it to the 4th power. Raise this to the 4th power. The 4th root raised to the 4th power is x. 1 times 1 times 1 times 1 is 1. Now listen to me, go back 2 problems. Remember we had a square root right here, and I told you whenever you square the number and it's positive, usually that answer will be a good answer. And whenever you're squaring a negative number like this, the very last step here, usually you'll get an extraneous solution here. And I said that only works when your powers are even, like 2, 4, 6, 8, 10. Well, notice I have an even power of 4. Notice the number I took to the 4th power is positive, so this answer here is probably going to work. And notice the number here I took to the 4th power is positive, so this number here is probably going to work. And guess what? They do. They both work. So if you take 16, trust me, and put it in, I'll try to do it real quick for you. 16 to the 1/2 power is 4. 16 to the 1/4 power is 2. And -3 times 2 is -6. And then bring up your +2. If you add those up, you'll get 0. Now let's test the number 1 real quick. If you put a 1 in for x, use your calculator. 1 to the 1/2 power is 1. Use your calculator. 1 to the 1/4 power is 1 times -3 is a -3, and then +2. All of those add up to 0. So we're good in all of this. We really are. And these are the 2 answers right here. All right, let me get a drink here real quick and we'll continue on. The last 2 look really scary, and they're not. I'm going to do something that I think you need to see. Notice how you have 2x minus 3 and 2x minus 3. I would like to make a suggestion that you let x equal 2x minus 3. And so for that group, I'm going to go ahead and put x for 2x minus 3 squared minus 5, and for this group put an x, and then +6 equals 0. I can do that as long as when I get down here to the end, everywhere there's an x, I go back in and use back substitution and put this back in, okay? Now, notice I have a quadratic trinomial, so I can definitely try to factor it. I have a +6 and a -5. The first 2 numbers that pop into my mind are these. If you multiply those, you'll get a +6. If you combine those, you'll get a -5. So I'm ready to jump right to my parentheses mode. These look really hard. These are really easy. They're easier than the last 2 problems that we did. Your middle term here is x, so I'm going to write x -2, x -3. And you think you're done, but hold on, we're going to go ahead and take one group and set it equal to 0, and we're going to take one group and set it equal to 0, but hold it, what do I have to put back in for x? 2x minus 3. So for x right here, I'm going to put 2x minus 3, then bring down your negative 2. And now look how easy this is to solve. 2x minus 3 minus 2. There's really nothing in front of your parentheses but a positive sign, so you really just have 2x, negative 3, negative 2 equals 0. Negative 3, negative 2 is negative 5. Bring the 5 over and make it positive, and then divide by 2, and you will get 5 halves. There you go. Not difficult at all. Now for this x right here, I'm going to substitute what? For this x, I'm going to substitute 2x minus 3, then bring down your negative 3. And then negative 3 would be 2x, negative 6 equals 0. And then bring the 6 over and make it positive and divide by 2, and x equals 3. Booyah. Pretty simple. There we go. There's your two answers. Let me get a drink here. One more problem and we're finished. This will be done the exact same way, so welcome to go ahead and pause the video and try it on your own if you haven't tried it. We're dealing with t's here. I guess were we dealing with x's in the last problem? Good, we were. We're dealing with t's here, so I'm just going to simply say that t equals, this is a little more difficult, so you might want to tag along on this one. T equals 2t plus 2. So now I can put t squared minus 4t plus 3 equals 0. Okay? And actually, you know what? I'm going to change something here. There's no reason to rock the boat here. I mean, we can definitely say x. There's nothing wrong with saying x because we're going to back substitute it out. So let's just leave it like we always do so there's no confusion. X equals 2t squared plus t. That's what x equals. So now this whole thing here becomes x. So I have x squared minus 4. This whole thing becomes x. So minus x positive 3 equals 0. There we go. Now, we're ready to factor, and right away I think of negative 3, negative 1. If I multiply those two numbers, I get a positive 3. If I combine them, I get a negative 4. So I'm ready to factor. Notice your middle term is an x, so I'm going to put x negative 3, x negative 1 equals 0. Now, when you get ready to take this group and set equals 0, be careful. What are we going to put for x? We're going to put 2t squared plus t. So I'm going to have 2t squared plus t, that went in for x right here, okay, and then minus 3 equals 0. Now this is a royal pain because now I have a quadratic equation I'm going to have to factor and deal with, but guess what? That's just part of higher level math. So we'll get to that in a second. Now for this x right here, I'm going to put 2t squared plus t, and then negative 1 equals 0. So unfortunately, I'm going to have to open another page to get some more room, and I'm going to go ahead and highlight these right here, and I'm going to drag them to the next page, and we're going to have to do a bunch of work here, okay? Which is okay. Work is good for us. And now we're going to have to solve each one of these groups. Well, this is a quadratic. We can definitely factor it. Notice how I do not have a lead coefficient of 1. So in my head, I take 2 times negative 3. That's a negative 6. And I'm thinking, okay, if I have a positive 3 and a negative 2, that gives me a negative 6. And if I combine those two, I get a positive 1. So I'm ready to factor this. 2t squared, then bring down your negative 3, bring down your equal sign, your 0, and right in the middle here I'm going to put a positive 3t and a negative 2t. And I got these two numbers from these two numbers over here. Now pull out what's common in your first two groups, and you're left with 2t plus 3. Pull out what's common in these two terms, and it's really nothing, but whenever this term here is negative, you pull out a negative, pull out a 1 because there's nothing you can factor out. And I would go ahead and write the exact same parentheses here that you have over here. I would put 2t plus 3 and then check it and see if it's right. Negative 1 times 2t is negative 2t, negative 1 times 3 is negative 3. So your parentheses do match, which they should. So the factorization would be 2t plus 3, and then you have t negative 1 Excuse me. So then we have t minus 1 for your other parentheses. Now, I'm not going to do this work for you, but if you take 2t plus 3 and set it equal to 0, bring the 3 over and make it negative, divide by 2, you will get negative 3 halves for this answer. Over here, if you take this group and set it equal to 0, bring the 1 over and make it positive, you'll get 1 for an answer. So far, back to our original problem, we have two answers, negative 3 halves and 1. All right, now let's go ahead and solve this group. Remember, we took this group here, set it equal to 0, okay, and now we're solving that group. Okay, we have a lead coefficient of 2, so 2 times negative 1 is negative 2, and I'm thinking, okay, if I take a positive 2 and a negative 1 and multiply them, I get a negative 2. If I combine them, I get a positive 1 right here. So those are the two numbers I'm going to use. Bring down your 2t squared, bring down your negative 1, your equal sign, your 0, and then right here in the middle, I'm going to put these two numbers in with t's. So I'm going to put a positive 2t and a negative 1t. Okay, factor out what's common in your first two terms. That would be a 2t, and you're left with t plus 1. Over here, pull out what's common. Looks like a negative 1. I'm going to go ahead and put t plus 1 here because that's what I have over here, and then I'll check it and see if that's right. Hopefully it is. Don't assume you're right. You could make a mistake somewhere. Negative 1 times t is negative t. Negative 1 times positive 1 is negative 1. So we're good. Your parentheses do match like they're supposed to, so you write t plus 1, and then you're left over with 2t minus 1. And that equals 0. Now, if you take this group here and set it equal to 0, you'll get a negative 1. If you take this group here and set it equal to 0, think about it, bring the 1 over, make it positive, then divide by 2, you'll get 1 half. So negative 1 and 1 half. And that's a great way to write your answer, no problem with that. Another way to write your answer could be negative 3 halves, comma, 1 half, comma, and then because you have a negative and a positive 1, you could put plus minus 1. Either way is fine, and you did it. Now these are really interesting equations, and hopefully you're understanding this, and if not, you might want to back the video up and watch some of these again, but they're not too difficult. They're time consuming, but they're definitely reasonable, okay? So there you go. I hope this homework help video has been a help to you. Call or email if you have any questions.